Okay, so on this question, a company manager wishes to test a union leader's claim that absences occur on the different weekdays with the same frequencies. Test this claim at the 0.05 level of series. If the following sample data have been compiled, find the p-value around 3 places. Okay, so absences on Monday 27, Tuesday 25, Wednesday 22, Thursday 23, Friday 33. Okay, what are we doing here? This is where I know what's hard for students. So perhaps for you, if you're a typical student here, is you read this and you go, man, I don't know what to do. They all are so similar. Which one is this? Is this, there's a million different tests. How do you know? How do you know? Well, first off, you want to do your best to really understand what it's saying. Especially the claim. Claim is the most important word in a hypothesis. Says what's being claimed. The union leader is claiming that absences, right? These number of absences down here, they occur on the different weekdays, like how many, absences on Monday or Tuesday or Wednesday or whatever. How do they occur? Same frequency. What does that mean? Same number. The union leaders say these are all the same number. Well, now, first off, you think, well, no, they're not. Those are different numbers. Well, yeah, but he means, yeah, they're a little different, but that's just because of random luck. In general, he's saying people are absent the same number of times on Mondays as they are on Tuesdays and Wednesdays and Thursdays and Fridays. It's all about the same. You see, what the union leader, why would they care about this? Well, the union leader always represents the employees, right? The union always backs the employees, and they're versus management. And so basically the managers are probably saying, hey, look, these employees are being bad. They're abused. They're being absent. They're calling in sick basically on Fridays and Mondays when they're not really sick because they just want to make their weekend go longer or start earlier, right? And we can see that sure enough, the Friday numbers and Monday numbers are a little bit higher than the Tuesday, Wednesday, Thursday. So it looks like there might be a little bit of truth to that. And the union leader saying, no, it's all the same. The fact that Friday came out just a little higher is just luck. It's just random variation. It's just luck. In general, they're all about the same. Meaning our employees are being honest. They're only absent when they're really sick. They're not just trying to extend their weekend. The union leader is claiming that absences occur on the different days with the same frequency. Okay, so we got to say, what do the data say? These are not all the same, but is that by luck? Or is that so far from luck that we say, no, there's something going on there? Where does the data point? Okay, so to figure that out, here's the key part, same frequency. What can we do for same frequency? We're asking if these numbers fit. It's a goodness of fit. If these numbers fit with them all being the same, that's what they're saying. The claim is they fit close to all the same number, same frequency. That's what the union leader is claiming, that it's a good fit. It's not that far off of all being the same. It's close to all the same number. Now, how are you going to know that on the exam? Well, first off, you notice there's no means anywhere. There's no averages or means. So it's not any of the means. There's not even any percentages anywhere, right? So it's a goodness of fit. Let me go down and find, there it is. I keep going by it right there. Here's the exam 4 notes. It's goodness of fit. And where can I see it? Right here, see same frequencies. There's the word we're looking for. It's under goodness of fit, same frequency. Right there. Okay, so anyway, what do we do? How do we do this problem? Well, that means put the observed values in L1. So I'm going to come back up here and I'm going to put the observed values in L1. That would be these values right here. So these values. So here, I'll just put them like this. L1 is going to be the 27, 25, 22, 23. That's observed. That's what we've seen. That's how the absences have gone. That's what's been observed. Okay, great. What goes in L2? Well, go down to the notes again. Goodness of fit. Calculate the expected values and put them in L2. How do you do that? Well, for equal distribution or same frequency, that's us, right? The union leaders claiming they're really all the same. They fit with being the same. Take the total number of values and divide by the number of categories. That's a divide there. So total number of values divided by number of categories. Total number of values divided by number of categories. Huh? Well, that's going to be, what's the total number of values? Well, I'm going to have to total these. So if you add all these up, total, so you have to add them all up. You got to get the total number. How many absences are there? Oh, yeah, I'm going to add my calculator. 27 plus 25 plus 22 plus 23 plus 33. So I'm just adding these up. I just add these up to get the total number of values, and it comes out to be 130. That's the total absences. So there's 130. So 130 absences divided by how many categories? Well, 5. You know, there's the categories are, were you absent on a Monday, Tuesday, Wednesday, Thursday, or Friday? And so that equals, what's that, 26. So that means L2 is 26 all the way down. Why are they all the same? Well, that's what the union leader is claiming, that they're all the same, right? So if they really were all the same, they would all be 26, because that would be all 130 absences. I added these up and found out there was 130 absences. Divided into 5 categories means if they're really all the same, if people are absent equally Monday through Friday, then they would have 26 absences on each day. See, that all comes from this keyword, same frequency. Same frequency. So put these in L1, put these in L2 on your calculator. Okay, and then what are we going to do from there? Oops, I'm going past it, aren't I? Right here. And then go to stat, test, chi-squared goodness of fit test. Degrees of freedom is going to be number of categories minus 1. It's going to be 4 in our case. This time, it's going to be, it's going to be 5 categories minus 1. It's going to be 4, because we have 5 days of the week, Monday through Friday. So there's 5 categories. Take 1 away. Degrees of freedom is 4. So put that into your calculator. So I'm going to go now to the calculator. I'm going to go to stat, over to test, down to whichever one that is. It's D. Chi-squared goodness of fit test. Because this is a goodness of fit. We're saying, how well do these observed absences fit with the idea of what the union leader is saying? They're really all the same. They're really all close to 26. Well, that 33 is kind of far. I don't know. Maybe that could be random variation, or maybe that's not very believable, random variation. All right, when you do that, you're going to get, what? You're going to get observed. It's L1, expected. It's L2. And degrees of freedom, we're going to make that 4. That comes from 5 categories minus 1, right? Because there's 5 days of the week there. Minus 1. So put that in, hit calculate, and enter. And when you do, I'm getting, oh wait, I didn't put my numbers in. Let me do that real quick. Okay, good. And then when you do, on this one, I get a p-value. That's what they're asking for, right? Find the p-value. I get a p-value of 0.571 rounded to 3 places, 0.571. And so there we go. So this one's a little tricky to recognize. Whenever you're seeing if one group fits with another group, that's goodness of fit. But it's hard to say, well, they don't say goodness of fit, but they say same frequencies. They're saying this fits with same frequencies. Same frequencies is one of our goodness of fit items. You see it in the notes here. Goodness of fit, same frequency. You really got to read these notes closely in the exam 4 notes. There we go.